children, hello, welcome to your home school this year, class 9 mathematics NCERT or CBSE board. Exercise 5.1, fifth problem. Let us see what it is. Line L is the bisector of angle A. Where is the line L? Line L is the bisector of angle A. What it is doing? It is bisecting, means this angle equal to this angle. Line L is bisecting the angle A and B is any point on the line. Let B be any point on the line L. BP and BQ. Observe the point carefully, children. BP and BQ are perpendiculars from B. Perpendicular from B to the arms of angle A. If this is your angle A, these two are the arms, right? Yes, if this is angle A, these two are the arms. From B, it is perpendicular to the arms of the angle A. It means it is perpendicular to BP and BQ. So once again, let's understand the problem. Line L is the bisector of angle A and B is any point on the line L. BP and BQ are the perpendiculars from B to arms of the angle A. Show that triangle APB congruent to triangle AQB. I need to prove that this triangle APB is congruent to triangle AQB. How can I prove? You can directly understand by seeing the figure. Where it is angular bisector, these two angles are equal. And this is perpendicular, right? 90, 90. And still, AB is a common side. So, which rule I am going to prove now? Angle, side. Angle, side. I can say that the two triangles are congruent. If they are congruent, what we can say? By CPCT, remaining parts I can make them equal. Let's start our solution here. Data, what is given? Given line L is the bisector of angle A and B is, say your children, in geometry, whatever the question there, we write almost question in answer. Now in data, we write the given data. What to prove? We write into prove. Point on L. BP and BQ are perpendiculars from B to the arms of angle A. What to prove, children? Triangle APB congruent to triangle AQB and BP is equal to BQ, or B is equidistant from the arms of the angle A. You can continue, children. Next, proof. How do we start? In triangle APB and triangle AQB. In triangle APB and AQB, what you can say? Angle BAP is equal to angle BAQ. Reason? Angular bisector. Line bisects the angle, right? Angular bisector. Next one. What you can say? Angle APB is equal to angle AQB. Reason? From B, perpendiculars to the arms of the angle. Given they are perpendicular. So, therefore, those two equal to 90 degree. AB. AB is equal to AB. AB is equal to AB. How you can say? By common. So, this side is common for the two triangles. Therefore, triangle APB congruent to triangle AQB. By what we are saying? Angle side rule. I say that these two triangles are congruent. Second one, if we know that triangle APB congruent to triangle AQB. If these two triangles are congruent, then what we can say here? By CPCT, I say that BP is equal to BQ. BP is equal to BQ. These two sides are equal. By CPCT, I can say that BP is equal to BQ. That's all, children. We need to prove this much, but don't by heart these problems. Just understand the concept. In your answer, almost half answer is filled by the question itself. Understand what is given, what I need to prove. Okay, what all is same, 90, 90, and angular bisector, these two angles are equal. Like this, we should be able to think a little. Right? Then the problems will be very easy. Sixth problem, in figure, AC is equal to AE. AC is equal to AE. AB is equal to AD. AB is equal to AD. But children, look here. Try to observe your triangles. Two triangles are like this there. So try to observe A, B, C, and one more A, D, E, A, B, A, D, A, C, A, E. Now it will be little clear, right? In figure, AC is equal to AE, AB is equal to AD, and angle BAD. Where is angle BAD? I cannot get here. So let me observe here. Angle BAD, this angle is equal to angle EAC. Show that BC is equal to DE. How can I prove this BC is equal to DE? If I able to prove this angle equal to this angle. You can say common angle, but observe here carefully. This part was missing. Observe carefully. This angle equal to miss angle A common. No, you may think, but no. Look here. In angle A, this part was missing. Either it may be for this triangle or for this triangle. For that triangle, this part is missing, and this triangle also, that part is missing. So, both the triangles, if this part is joined, then I can say angle equal to angle A. Then what happens? Side, angle, side, side, angle, side. Both the triangles are congruent. If they are congruent, by CPCT, BC is equal to DE, I can prove. This is the way we need to prove these type of problems. So, let's start. Solution. Given AC is equal to AE and AB is equal to AD, and one more, angle BAD is equal to angle BAC. Show that to prove BC is equal to DE. Let me start my proof. How can we start, children, here? Consider the triangle BAC and triangle DAE. Triangle BAC and triangle DAE. Let us start comparing these two triangles. According to the given data, what I can say? AC is equal to AE. AC of this triangle is equal to other triangle AE. And AB of this triangle is equal to AD of other triangle. Now, they have given angle BAD is equal to angle EAC. Where is angle BAD? This is given data, children. I am not saying through the triangles. Given angle BAD is equal to angle EAC. So for these two triangles, what is missing? We have said this part, right? Let us add that part. Adding angle DAC on both sides. What happens? If for this, if that piece is joined, only up to here it was there before and up to here it was there. So this small part was missing. Here also small part was missing. Now if I add complete angle, it becomes. Now adding angle DAC on both sides, that is angle BAD plus angle DAC is equal to, add DAC, angle DAC plus angle EAC. Angle BAD plus angle DAC is equal to angle DAC plus angle EAC. Now observe here, angle BAD plus angle DAC will be angle BAC is equal to this angle, angle DAC plus angle CAE becomes angle DAE equal. Now what we need, that angles are equal. Therefore, what I can say here, by side angle side rule, I say that triangle BAC is congruent to triangle DAE. If they are congruent, by CPCT, I can equate the corresponding parts, corresponding sides. Therefore, BC is equal to DE. How we can say? By CPCT, the remaining sides or remaining parts are equal. Seventh problem. AB is a line segment. AB is a line segment and P is its midpoint. Immediately what I remember, children, if P is a midpoint, automatically AP is equal to PB. Given AB is a line segment and P is a midpoint, therefore I can say AB is equal to PB. D and E are points on the same side of AB. D and E are the points on the side of AB such that angle BAD, observe, angle BAD is equal to angle ABE and angle EPA is equal to angle DPB. You can see a single arc and here double arcs, right? This angle equal to this angle equal to this angle. Here they have given it is a midpoint, therefore two sides are equal. Now what I need to prove here, show that triangle DAP, observe DAP children, this is a triangle DAP. So let me draw separate DAP, okay, and triangle EBP. Where is EBP? BP. So like this, just rough figure we have drawn. PB, this is E and this is D. Prove that these two triangles are congruent. But what given in the figure? Observe carefully. Angle A, angle B, okay. Angle P, see there children, concentrate carefully. Where is angle P? Angle APD, this part is missing. Can you observe? Means I know only this much part of angle is equal. And here when I talk about EPB, only this much part of the angle is equal said. Then what about the remaining part? Remaining part missing. Then I can't say that angle P is equal to angle P. I can't say. Then what I need to do? Similar problem we already have done. So there what did we do? We have added the missing part. What is the missing part, children? This angle you just add for this and also for this. Then what happens? Then if you add, complete angle will be equal. At that moment, angle side angle rule, I can say the two triangles are congruent. Ready? Let's start. And one more, AD is equal to BE. If two triangles are congruent, then by CPCT I can say AD is equal to BE. Yeah, solution. Given data, AB is a line segment. P is its midpoint. Still, what did they say here? Midpoint. D and E are the points that all you can write, children, of such that what is given, angle BAD is equal to angle ABE and angle EPA is equal to angle DPB. Show that. To prove, what we need to prove? First one, triangle DAP is congruent to triangle EBP. And second one, AD is equal to BE. Right? Now first, proof we start here. In triangle DAP, and I am using here, and triangle EBP. Now consider these two triangles and then start comparing here. How can you compare? Angle DAP. But given, what is given? Angle DAB given. DAB means up to here there, but I don't want this. I will end with P. As I am comparing this triangle, angle DAP is equal to angle EBP. How I can say? Given. Right? So next angle or next side you can say. P is midpoint. P is midpoint, right? Therefore, I will say AP is equal to PB. Then one more angle. What is a given angle here? Given angle, let us take. Angle EPA is equal to angle DPB. This is given, children, but I cannot write for this triangle. For these angles, let us add this angle, children. That is angle EPD. Add on both sides. Angle EPD plus angle DPB. Right here, 1 point. Adding on both sides. EPD. This angle adding for this angle and this angle adding for this angle. So where it is, what you are talking is this angle and here this angle. One part of the angle is added here. Then what happens? It becomes EPA plus EPD. EPA plus EPD becomes angle APD. Angle APD. And angle EPD plus angle DPB, this plus this becomes this complete angle. That makes BPE. Angle BPE or EBP also you can write, children, no problem. Then these two angles are equal. I can say that, therefore, by angle side angle rule, I say that triangle DAP is congruent to triangle EBP. Therefore, angle side angle, I can say the two triangles are congruent. First case is already proved, and your second case, how can I prove? We have proved now that, what is that? Triangle DAP is congruent to triangle EBP. If they are congruent, by CPCT, I can equate other sides. That is, AD is equal to BE. By CPCT, I can prove that one. Therefore, hence it is proved. The two cases are proved. Let's see the last problem of this exercise. That is your 8th problem. In right triangle ABC. Children, observe here, right triangle ABC. Right angled at C means this is right angled. In right triangle ABC, right angled at C. M is the midpoint of hypotenuse. This is the midpoint it seems. M is the midpoint of hypotenuse. That means, midpoint means immediately I can say BM is equal to AM. Hypotenuse AB. C is joined to M. C is joined to midpoint. So, join C and M and next and produce this M to a point D such that DM is equal to CM. Now, read one more what we got here. Two pairs of sides are equal we got. Next, such that DM is equal to CM. Point D is joined to point B. Show that you need to prove these all cases. 4 cases are there here. So once again understand the problem here. In right triangle ABC, right angled at C, a point M is the midpoint of the hypotenuse. Midpoint means immediately BM is equal to AM. And next point, C is joined to M. C is joined to M. Okay. Next, and produced. Produced means this line is extended to a point D such that DM is equal to MC. Point D is joined to a point B. Show that these 4 cases. Okay, let us start our proof. How can we start, children? Write all the given data. How can you write? Space is very little for all the 4 cases. So, given data and what to prove, I just say oral. Given data. What is the data given? ABC is a right triangle. Next line. Right angle at C. M is the midpoint of the hypotenuse AB. And extend, join MC. Extend to meet at a point D. Then join BD. Given DM is equal to MC. This is all you write in the given data. Then proof. We need to prove. To prove these all we need to write. To prove, write the statement and then write all the 4 cases. Now let us start our proof of first case, children. Consider or in triangle AMC and triangle BMD. Where is AMC triangle? This one. Can you have a look here? This is AMC and this is BMD. AMC, BMD, I need to prove those 2 triangles are congruent. See here, children, by observing I can say directly. How? And side, 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 side. These 2 angles are vertically opposite to one another. Therefore, by vertically opposite angles, these 2 angles are equal. Let us write here. First point, given M is the midpoint. M is midpoint. Means AM is equal to MB. I have taken first which triangle? AMC. So, I should write left side AM. AM is equal to MB or BM you write. Next step. Next step we have done the construction, right? CM is equal to DM. This is also given. Next point. Angle AMC is equal to angle DMB. How you can say this angle equal? Vertically opposite angle. See children, this angle I am saying equal. By vertically opposite angles, angles are equal. If these 2 angles are equal, what I can say? By side, angle, side, side, angle, side. By SAS rule, I say that the 2 triangles are congruent. Triangle AMC congruent to triangle BMD. Okay, this is the proof for first case. Let's start proving the second one. Angle DBC is a right triangle. Where is angle DBC, children? This angle is a right angle. I need to prove. How can I prove this? We know that we have proved these 2 triangles congruent. By using that I try to prove. So see here, we know triangle AMC is congruent to triangle BMD. This AMC is congruent to BMD. Therefore, what I can say, angle ACM is equal to angle BDM. How did I write, children? I am saying this angle is equal to this angle. By CPCT, corresponding parts of the congruent triangles are equal. According to CPCT, I can say this angle equal to this angle. So immediately what I can remember, it looks like a transversal. Alternate angles are equal. If alternate angles are equal, so it makes that alternate angles are equal. Therefore, I can say that DB and AC are parallel. DB and AC are parallel. That is, DB is parallel to AC. DB parallel to AC. Yes, how we got, children? We try to prove that if two triangles are congruent, corresponding parts of a congruent triangles are equal. So I have taken this angle equal to this angle. If you want, you can say this side is equal to this side also. Right? So this angle equal to this angle, then I can see a transversal. Alternate angles are equal. If alternate angles are equal, automatically the lines are parallel. Which lines? DB is parallel to AC. Then again, you can observe here DB AC are parallel if I say. So again, the line what it looks BC, it is also looking as a transversal. So sum of the interior angles of the transversal, what you can say, children? Angle, you can write the statement. The sum of interior angles of transversal. What is a transversal now? BC is also a transversal. Angle DBC plus angle BCA is equal to 180 degrees. The sum of the interior angles of a transversal will be 180. I know that BCA angle is 90. DBC plus 90 degree is equal to 180 degree. Send this 90 other side. Angle DBC is equal to 180 degree minus 90. Angle DBC is equal to 90 degree. Yes, this is only the thing we need to prove. Therefore, angle DBC is a right angle. Now coming to a third case. Triangle DBC congruent to triangle ACB. So this case was moved up to here. Observe here carefully. Triangle DBC. Let us take a rough figure here. DBC. Right angle we got. Now this one also. And this one is C, right angle. BA. Now compare these two triangles. DBC and ACB. Okay. So what you can say, by seeing these two triangles, I need to prove congruent. I will write here, as before case, I was able to prove this angle is also 90. Therefore, angle DBC is equal to ACB is equal to 90 degrees we got. And compare here BC common. BC is equal to BC or CB you can write common. And still anything there, observe carefully. I was able to prove these two triangles are congruent. When these two triangles are congruent, these sides are equal by CPCT. Let me prove that. By first case, I can say that DB is also equal to AC, as I have proved in case 1. If in these two triangles, we try to prove these two triangles are congruent. If they are congruent, corresponding parts are equal. DB equal to AC. So now, if I make that one DB equal to AC, now again I got angle side rule. I can say that these two triangles are congruent. Which are congruent, children? These two triangles are congruent. Triangle DBC is congruent to triangle ACB. Look into the last and final case of this problem. That is CM is equal to half of AB. How can I prove this one? So when I compare these two triangles, I was able to prove that triangle DBC is congruent to triangle ACB. If these two triangles are congruent by CPCT, I can say that DC is equal to AB. What is the DC? Look here. DC is equal to AB. DC means what? 2 times CM. DC, I am going to write it as 2 times CM is equal to AB. This 2 multiple and this side. CM is equal to half of AB. I didn't do anything, children. Each and every case we have linked and we was using CPCT and we are equating one side and angle and then we are substituting here. So look carefully. Last case DBC, these two right angles are congruent. If they are congruent, corresponding sides or corresponding angles we can equate. So according to that I have taken these two angles are equal. If DC is equal to AB, what is DC? They have said M is a midpoint. DM is equal to MC. So 2 times CM, can we write DC? Yes. 2 times CM is equal to AB. And this 2 if you send other side, CM is equal to half of AB. With this, there is an end of this exercise. Exercise 5.1 is completed. In our next session, we are going to continue with the theorem. Right? Until that, keep watching. Thank you all.